Assalamualaikum dear student, this is Wajid Risha, and today we are going to discuss the atomic spectra chapter 19. The first topic is the Bohr model of hydrogen atom. To discuss the structure of the atom in 1909, initially J.J. Thomson represented a model which is called the pudding model. According to this, all the positive and negative charges are evenly distributed over the entire surface of the atom. Then, another scientist, Rutherford, represented another model after the alpha particle scattering experiment and discovered the nucleus. After that, in 1913, another scientist, Niels Bohr, proposed another atomic model of the hydrogen atom, which contained ideas from the classical physics, Planck's theory, Einstein theory, and Rutherford model. Bohr theory can be explained in the following 3 points. The first point: electrons move in circular orbit about the nucleus under the influence of Coulomb force of attraction between the electron and the positively charged nucleus. mv square over r, which is the centripetal force, and this centripetal force is coming from the Coulombic forces, Ke square divided by r square, according to Coulomb's law, the force of attraction between positive and negative charges. This is the first point, that electrons are revolving around the nucleus in circular orbits, and centripetal force is provided by the Coulombic force coming from nucleus of the atom. Second point, only those stationary orbits are allowed for which orbital angular momentum is equal to the integral multiple of h divided by 2 pi r. Mathematically, we can write mvr is equal to nh divided by 2 pi. So angular momentum is the integral multiple of h divided by 2 pi. We can say that according to this, we can conclude the wavelength of the photon should be comparable or equal to the circumference 2 pi r of the orbit in which the electron is revolving, or it intends to revolve. Point number 3. Atom radiates energy only when the electron jumps from one allowed stationary orbit to another energy. The energy difference can be written like delta E is equal to Hf is equal to En minus Ep. If electron stays in a single orbit, so it does not radiate energy, but when electron jumps from one orbit to another, so it emits energy. These are the 3 points of the Bohr atomic model. Based on this atomic model, we are actually going to derive some results for the Bohr theory. The first result is about the quantized orbit. He basically presented an idea of the quantized orbit. As we know that mv square over r is equal to ke square divided by r square. This is the first postulate of Bohr theory, and also the second postulate is mvr is equal to nh divided by 2 pi. Using these first two postulates, we actually want to find the radius of the orbit. So from equation 2 we can find the value of v, like mr matlab we are actually going to derive an equation for the radius of the orbit in which the electron is actually revolving. So the technique is that we will find the value of v from equation number 2 like this, where v is equal to nh divided by 2 pi mr, and we will put this value in equation number 1. So from equation 2 we can have v is equal to nh divided by 2 pi mr. Putting this value of v in equation number 1 here, so we can say that mv square over r, this is v actually, so mv square over r is equal to ke square over r. Okay, now m n square h square divided by 2 square pi square m square r square. We will write this term here, and this r will be at its own place, is equal to k square divided by r square. Cancelling r square from both sides, we can write m n square h square divided by 2 square pi square m square r is equal to k square. R square cancels. So finally we can write r is equal to m n square h square divided by 4 pi square m square Ke square. Cancelling 1 m here, like with this one, and we have n square h square divided by 4 pi square m Ke square, where n is the principal quantum number which shows the orbit number which is variable, and rest of the values are all constant. H, pi, m, Ke, these are all constants, so we can put the values of these constant in order to have the value of the equation as we can put this whole term in the form of R1, where R1 comes out to be equal to 0.053 into 10 raised to power minus 10 meter. So according to this equation, the radius of the orbit is quantized. For n is equal to 1, we will have this value. For n is equal to 2, we will be changing the value accordingly. So this radius is actually the integral multiple of the principal quantum number. So this shows that the radius of the orbit in which the electron is revolving is actually quantized. Now, second result of the Bohr theory, it is quantized energy. Quantized energy is according to the Planck's quantum theory. The energy can be calculated according to the quantized radii concept. We can calculate the total energy by the equation. As we know that total energy is the sum of the potential and kinetic energies. So, where kinetic energy of the electron is given by 1 over 2 mv square, and we already having from the first postulate, we know that mv square is equal to Ke square divided by Rn. So, 1 over 2 mv square, and actual value of the kinetic energy of electron revolving in an orbit is 1 over 2 Ke square divided by Rn. So, using the first postulate, we can have this value of the kinetic energy of the electron. Also, the potential energy is equal to minus Ke square divided by Rn. Using these concepts, these ideas, where we know that W is equal to Q into V. Instead of Q, we will put here E, a symbol of charge, and V is the electric potential, which is having the value Ke divided by R. So using this, work done is equal to potential energy. We can have potential energy minus K square over Rn. Now the total energy is given by the sum of these kinetic and potential. So potential energy plus kinetic energy, solving these two, we can have total energy of the orbit minus 1 over 2 K square divided by Rn. Now put the value of Rn in the above equation as already calculated in the previous part of the results. So Rn is having a value h square 4 pi square Ke square m. We will put this value of R in equation number second, and having the idea of the total energy, like total energy is equal to minus 1 over 2 K square, and this is the value of R which we will put here. So total energy is equal to minus 1 over 2. Simplifying and rearranging these equation like Ke square instead of its own place, and 4 pi square Kme square will be taken up to the numerator, n square h square. Rearranging, simplifying the equation step by step, we will finally have this equation, that energy of the n orbit is equal to 1 over n square K square E4 4 pi square m divided by 2 h square. These are all again constant, and we can write these constant values, and can find that the total energy E naught, which is a constant, 13.6 electron volt energy. So we can have this equation like the general equation for the quantized. Again, we have the n is the principal quantum number, which is again integral value, like n is equal to 1, n is equal to 2, n is equal to 3. So En is equal to minus 13.6 electron volt divided by n square. For n is equal to 1, we can write E1, and finally 13.6 electron volt energy of the electron is inside the orbit. If we want to remove the electron from that orbit, we will have to provide the amount of energy equal to 13.6 electron volt. When we are talking about the second orbit, so we will put n is equal to 2, and that is minus 13.6 divided by 2 square, n square. So we will put the value of n like 2 square. So 2 square is equal to 4. We will divide 13.6 by 4. It means the ionization energy of the electron in the higher orbit will be comparatively greater. So energy of the electron in the uh, higher energy orbit will be greater. It comes out to be 3.4 electron volt. Now the third result of the Bohr theory, it is actually hydrogen emission based on the Bohr theory. For example, we have an electron in n orbit and we want to take the electron from n to p orbit, so photon will be emitted. Electron is de-excited and the photon is emitted. So the energy of the electron in this orbit is given by this equation, n orbit, and the energy of the electron in p orbit is given by this equation. So the difference of the energy is actually the energy of the photon. So difference of energy is actually the difference of the energies of the photon. So putting these values, we can write En is equal to 13.6 divided by n square minus 13.6 divided by p square. It is actually the difference of the energies. So minus minus multiplies and it comes out to be, when we multiply minus with this minus, so it becomes positive and we can write positive here. So and negative is transferred here. Okay, so we can write as we know that 13.6 is equal to E naught. It is a constant value, so we can write that delta E is equal to E naught. We can take E naught as common outside of the bracket, 1 over p square minus 1 over n square. So delta E is equal to hf, as we already know that from Planck's quantum theory, E is equal to hf. We will put hf here. Again, we know that C is equal to f lambda for a photon, so we can write f is equal to C divided by lambda. So putting these values here in this, instead of E we will put hf. Again, instead of hf we will use C over lambda. So is equal to E naught 1 over p square minus 1 over n square. So 1 over lambda is equal to E naught divided by hc. hc will be transferred here to the denominator on the other side of the equation, and 1 over p square minus 1 over n square. This is actually the emission spectrum hydrogen, which was actually derived by the Balmer in the previous topics, and again it is derived by the Bohr theory. So it means Bohr theory is valid in explaining the emission spectrum of hydrogen. Thank you. Have a nice day.